Okay, so here's problems 46 and 52 from section 10.3. So 46, it says, if any 2 points determine a line, how many lines are determined by 7 points in a plane? No 3 of which are collinear. Okay, so let's just think about that. So I'm just randomly selecting points that are not collinear. I guess it really doesn't matter. How many have I got there? 6, 7. So you just got to make sure that 3 are not on a line. So two of course can construct a line, but as far as that's concerned, so let's just draw some. So that we got to come up with a different way of doing this, but now one thing that you may think I've done, but actually, oops, didn't mean to do that. You've also got situations like this. So I could connect these two with a line. I could connect these two with a line, and I could connect those two with a line, and connect those two with a line. So there are, but what you have, as you think about it, if you have a line, if you give each one of these, points a letter, so they're going to be 7 letters. So 1, 2, 3, 4, 5, 6, 7. So a line is defined by 2 points, and so you'd have, AB, line AB, but line BA is the same as line AB. So basically what we're doing is we're taking 7 letters, and we're going to group them 2 at a time. And if we group them, they're going to become a line. But order is not important. So what does that sound like? 7 letters, 2 at a time. Order is not important. That sounds like a combination problem to me. And so all we have to do is take 7 things, taken 2 at a time, which is 7 factorial, 2 factorial, 7 minus 2 factorial, 7 times 6 times 5 factorial, divided by 2 factorial, 5 factorial. 7 minus 2 is 5. These cancel out. So you can have 42 divided by 2 times 1, so 42 divided by 2. So the answer is 21. But the key thing here is not to try to draw all these lines. It's just to, and it's kind of something that's not obvious. And I actually didn't come to me until I started drawing these lines and thinking, oh yeah, each line is defined by 2 points. And the reason they can't be collinear is if they were, then you could you'd have the same line defined by more than 2 letters. So that's the key thing there. Okay, 52. Selecting committees. 9 people are to be distributed among 3 committees of 2, 3, 4 members, and a chairperson is selected for each committee. How many ways can this be done? Break the task into the following sequence of parts. So that's helpful. So it says select the members of a 2-person committee. So it's a committee. So we have 9 people taken 2 at a time. Select the members of the 3-person committee. So this is like the problem we did in the book. Except if you've chosen 9 people, then you have 9 people, you choose 2, there's only 7 left. So then you have 3 people left. I mean, you've taken 3 people, and then finally you've got 4 people taking 4 at a time. And that's the reason they don't ask for that, is because that's 1. Now, the next thing you do, part C, is the chair of the 2-person committee. So what you do is you take the 2 people and you choose one of them to be the president and one to be the chair and everybody else to be whoever they are. So you can use combinations or permutations that give you the same number. Likewise, for the 3-person committee, you've got 3 people, you're going to pick 1 person. And the 4-person committee, you got 4 people, you pick 1 person. So you can do them as combinations, or you can remember if this is 1, then the number is associated with the first part of the combination expression. So it's a 6-part process. Choose the 2-person committee out of 9, choose the 3-person committee out of 7, choose the 4-person committee out of 4, then go back and choose the chairman for each committee, chairman for each thing. So all we have to do now is figure out what these 2 are. This is 1, 2, 3, 4. So let's see, 9 things taken 2 at a time is going to be 9 factorial over 2 factorial minus 9 minus 2 factorial, which is 9 times 8 times 7 factorial over 2 factorial times 7 factorial. Those cancel out. That's 9 times 8 divided by 2 times 1. So that's 72 divided by 2 is 36. And then 7 things taken 3 at a time is going to be 7 factorial over 3 factorial times 7 minus 3 factorial, which is 7 times 6 times 5 times 4 factorial divided by 3 factorial, 4 factorial. So 7 minus 3 is 4. Those cancel out. Remember, this is 3 factorial, not 3, so you got to divide by 3 times 2 times 1. So if you multiply that out, you'll get 35. Now the reason you can use your calculator to do that, but what I did is 3 times 2 is 6. I just left 7 times 5, 35. Okay, so now we multiply all of these things together. So this one's 36, this one's 35, this one's 1, 2, 3, 4. So multiplying all those things together. Get my calculator out. Thirty-six times 35 times 1 times 2 times 3 times 4 is 30,240.